Hello everyone, my name is Nate Katz,
I'm Kyra Warnke.
I'm Ahmed Tawfig.
and the cable link we chose for this demonstration was a Cat5e Ethernet cable along with an RJ45 connector. The purpose of selecting the cable was to show the different connections and how they affect the throughput.
These diagrams show two different wiring configurations for the RJ45, the 2568A and the 2568B. Both are widely accepted wiring configurations that can be used for different purposes, such as computer-to-computer connection versus computer-to-router connection. First, we will demonstrate the T568B configuration, as this is preferred in the United States for networking. To terminate the Cat5e RJ45 connector, we must first align the wires correctly according to the diagram. This is very important, as we will later show what happens if this step is done incorrectly. We then ensure the twisted pair wires are straight before cutting them to prepare for the RJ45 connector. After inserting them into the connector, we use a special RJ45 crimper to crimp the connector and make sure everything is secure. We will now demonstrate the wiring diagram for the T568A configuration. To do this, the process is very similar. However, the green twisted pair and the orange twisted pair are swapped. To test what happens when the configurations are both used, we kept the other end of the cable configured as T568B. This creates crossover. This can create problems depending on the use for the link. For a third demonstration, we terminated the link one more time using neither of the configurations mentioned, and created a split pair. This occurs when a twisted pair is in the wrong position of the wiring. We will now show the results of each configuration.
The standard for working with twisted pairs is to ensure that the wires that terminate at the connectors are properly aligned. Thus, for our first test, we terminated the cable link such that both RJ45 connectors adhere to the Type B configuration for a straight-through connection. In that test, we saw that the measured throughput of the connection from and to the computer was around 402 megabits per second and 412 megabits per second, respectively. In the case of cross configuration, meaning that one end of the cable had a Type B configuration and the other had a Type A, we noted that there was negligible performance differences when compared with the first test. Lastly, we intentionally misaligned the wires to the RJ45 connector and attempted to test the connection of the link. Naturally, there was no connection to measure. This is because the split wires at the connectors, that being the transmit-receive wires, were connected to the wrong pins. To explain why there was little to no difference between the first two tests, network ports include a feature known as auto-medium dependent interface crossover that detect misalignments between connectors and auto-reconfigures the transmit and receive line to work in the event of crossover cables. One thing that the group enjoyed was the hands-on experience of experimenting with real-time networking performance. As for areas of improvement, the team as a whole would benefit greatly from more experiences with crimping wires and aligning them with pins. Thank you all for watching.